Hi, everybody, welcome to Math 70. This is the video for section 1.3. The name of this section is literal equations, but what that really means is equations in more than one variable. Now this, like the other section, is going to be one step beyond what we've already learned, but it's not brand new. So as a reminder, equations in one variable might look like 2x plus 1 equals 11. That's an equation in one variable. And we can solve this equation for x. And the way we're going to solve that is by subtracting 1 from each side, which gives us 2x equals 10, and divide both sides by 2, which is going to give us x equals 5. Equation in more than one variable simply has more than one variable in the equations. So for example, and in particular, it's not just x more than one time, it's actually two different letters representing two different variables. So let's look at an equation in two variables, x and y. So an equation in two variables just has both the x's and the y's, and it needs to have an equal sign, something like that. So this is an equation in two variables. Instead of having one unknown, we have two unknowns. Now, I can't figure out from this equation a single x value that makes it true because I don't know the y value. But what I can do is I can write it so that x is all by itself on the side. So solve for x means get x equals on one side and everything else on the other. So if I do that, and if I solve 2x minus 3y equals 10 for x, I'm going to treat the 3y as a single unit, as a single term. And instead of adding just 3 or instead of adding just y, I'm going to add the 3y to both sides. And I get 2x equals 10 plus 3y. And then I'm going to divide both sides by 2. I have to be careful. I'm going to divide everything by 2. So I'm going to divide the whole right side by 2. And I get x equals 10 plus 3y over 2. This is solved for x. Well, there's an alternative mathematical operation to do here. That's the same operation. And so I want to show you how it would look a little bit different. If I have 2x minus 3y equals 10, I'm still going to add the 3y, to both sides. And when I divide by 2, the first time I divided everything by 2, I'm also going to divide everything by 2, but I'm going to do each part separately. And I have x equals 5 plus 3 halves y. These two are equivalent to each other, but they look a little bit different. Either one is correct, so either one is okay. And that's how you solve a literal equation or solve an equation in two variables. Let's just do a couple more examples. let's see, let's solve. I'm gonna use different letters this time. A plus 3b equals minus 10b plus 2a plus 9. I'm going to solve all of this for a. So it's an equation that has two unknown variables, a and b, and I want to solve it for a, which means at the end, I should have an a equals on one side and everything else on the other. To do that, I'm going to collect all the a terms. So let's subtract 2a from both sides. And I get minus a, because a minus 2a is equal to negative 1a. Minus a plus 3b equals minus 10b. That cancels, plus 9. Now I'm going to get everything that's not an a over to the right side. So I'm going to subtract 3b from both sides. And I get minus a equals 10, negative 10 minus 3 is negative 13. So negative 13b plus 9. I'm almost done because that's not a by itself. That's a negative a by itself. Negative a, I can get rid of the negative by multiplying it by negative 1. And now I'll have a on the right side. And the negative 1 is going to multiply and distribute to each of these. So the negative 13b times negative 1 and the 9 times the negative 1 gives me 13b minus 9, and now I'm done. This equation here is mathematically the same as the one I started with at the top, but now it's written so I have one a on the left and everything else on the right. So whatever value you pick for b, I can figure out what a is. Let's solve this same equation. Let's solve it for b instead. I can do that. I can solve it for either of my variables. So in this time, I'm going to get all the b's on one side. So let's add 10b to both sides. And I get 13b, oh sorry, a plus 13b equals 2a plus 9. Now let's subtract a from both sides, and I get 13b equals 2a minus a is a. So 13b equals a plus 9. And then I'm going to divide both sides by 13. I'll do them individually here this time. I usually do them individually. And I have b equals a over 13 plus 9 over 13. So I have solved the same equation first for a and then for b. This is nice because if this is the amount of money you pay and this is the amount of donuts you buy, then if you know you bought 10 donuts, you can easily figure out how much money you paid. Or if you know you paid $100, you can figure out how many donuts you bought. All right, so it's a way to relate your two unknown variables to each other. All right, let's do another one. I'm going to jump it up and do 3 variables in this equation. Let's solve 5x, y, z equals 75 for x. So I have an equation now with 3 variables, 3 unknown variables, and I want to solve it for x. So I want to get it look like x equals, well, I have 5 times x, so I could divide everything by 5. And that gives me x, y, z equals 75 over 5, which is 15. Now the x and the y and the z are all multiplied together, so I have to divide by y. I'm not subtracting y, I have to divide by y, which gives me xz equals 15 over y. And now I'm going to divide both sides by z. And this gives us a chance to talk about what do you do if you have a division with another division? Well, when you have one division divided by the other, that's the same thing as putting both the division, oops, that's a y. Let me start over. When you have one division divided by another, or one fraction divided by another number, that's the same thing as putting both of the denominators together multiplied. So x equals 15 over y times z. And I just want to point out a slightly faster way to do this. If I started with 5xyz equals 75. I got the x and I'm multiplying it by a 5yz. So I could do the 5yz all at the same time. And I get x over 75 divided by 5 gives me the 15 and the yz like that. So I went step by step the first time, but usually the way I will do it is I will divide by everything that's multiplying all at once. Let's just do a couple more examples. 5, now I'm going to multiply it by a parentheses, 3x minus 7y equals negative 60y. And let's solve this for x. Couple of ways to do this, actually. We have an option. We could divide by 5 to get rid of the 5, or we could distribute and multiply both of them by 5. I think I'll do them both ways. So let me do it the divide by 5 way first. So I'm going to rewrite it. Divide both sides by 5. Since it's a multiplication, that will cancel the 5, giving me a 3x minus 7y. And then minus 60y over 5 is minus 12y, because 60 divided by 5 is 12. And then I'm going to add 7y to both sides. And I get 3x equals 5y. And then I'll divide both sides by 3. And I get x equals 5/3 y. That's probably how I would do it. I would first undo this multiplication instead of distributing it through. But just to show you, let's distribute it through. I'll rewrite it again. And this time I'm going to distribute that 5 through, and 5 times 3 is 15, and 5 times 7 is 35. So I get 15x minus 35y equals minus 60y. Then I'll add the 35y to both sides. And that gives me 15x equals, that's going to be 25y. And then I'll divide both sides by 15. And I get x equals 25 over 15y, which looks different, but 25 is 5 times 5, and 15 is 3 times 5. And when those cancel, we still get 5 over 3 times y. Okay, next topic for this section is a special way to write linear equations that have two variables, which is called slope-intercept form. And we'll spend more time on this in another section. But in general, an equation that has two variables can look a lot of different ways. But if I let x and y be the variables and always solve for y, I get what is called slope-intercept form. So let me give you a couple of examples. Here's an equation that has an x and a y. It's already solved for y. This is slope-intercept form. If I have an equation that looks like, let's see, negative 2x plus y equals 8, I can solve that for y by adding 2x to both sides. And I'm going to get y equals 2x plus 8. That's also in slope-intercept form. Even if I have something complicated, like 13x minus 10y equals 5 times 2 plus x plus y minus 8, I can solve this for y, and I will end up with a y equals a number times x plus another number. So let's do it. This time I'm going to multiply through. I'll distribute the 5 through each of those, and so I'm going to get a 13x minus 10y equals 5 times 2 plus 5 times x plus 5 times y, and then a minus 8. 5 times 2 is 10, and the minus the 8. So I'm going to end up adding 2 because I have 10 minus 8 equals 2. And I'm solving for y, so let's subtract 5y from both sides. And because I'm running out of space, I'm going to subtract 13x from both sides as well. Negative 10y and negative 5y gives me negative 15y. And 5x and negative 13x gives me negative 8x. And then I have the plus 2. And divide both sides by negative 15. That's a negative 15. And I'm going to get y equals 8 over 15 times x minus 2 over 15. So I still got it into slope-intercept form. Any linear equation that has two variables can always be written in slope-intercept form by doing this algebra. The general form, the general slope-intercept form is y equals some number, which is the slope, times x, plus another number, which is the intercept. And we usually use the letter m for slope. I don't have any idea why. And the letter b for the intercept. It's called slope-intercept form because if we go from the symbolic version to a graphical version, this number is the slope of the line, and this number is where the line intercepts the y-axis. So as an example, let's look at y equals 2x minus 3. That's slope-intercept form. So if I were to draw this on x, y axes, I would know that the slope, I would get a straight line and the slope would be 2, and it would cross the y-axis at a height of negative 3. Slope is the rise over the run. It's how many units it goes up divided by how many units it goes over. 2 means it goes up 2 units and over 1. Up 2 units and over 1. Up 2 units and over 1. And so it would connect into a straight line that looks like this. Let's do another one just to practice. Let's see. Let's do find the slope intercept form of let's see, 5x minus 3y equals 9. So the first thing I would do is I would take my 2-variable equation and I would solve for y, which involves subtracting 5x from both sides. And that gives me 3y equals minus 5x plus 9. And then I'll divide both sides by 3, and I'm going to divide them individually. And I get y equals, oh, that should be a negative. Negative 3y, which means I have to divide by a negative. Minus 5 divided by minus 3 is 5/3 x, and 9 divided by negative 3 is negative 3. So now I have slope-intercept form. That tells me that the slope is 5/3, and the intercept is negative 3, so it's here at negative 3. The rise over run is 5 up divided by 3 to the right. So when I take 1, 2, 3 steps to the right, I go 5 steps up, like that. And then I'm going to get a line that connects this way. All right, that's the basics of slope-intercept form. There's a lot more to say about it. That'll come in another video. Thanks for watching.